Hey there, STEM enthusiasts! Welcome back to Kameron's Lab, Dive In, the go-to podcast for STEM students, crafted with passion by one of your own. I'm Kameron, your enthusiastic and ever-curious host. Buckle up for today's insightful episode. Ready to dive in? Hi everyone, welcome back to Kameron's Lab. Today I'm really excited to be joined by Miss Sophie Harker, so I'm just going to give you a quick introduction to her because I can't miss out on any of her accolades. So she is currently the Assistant Chief Engineer of Electric Products at BAE Systems, and she has her Master's in Mathematics. At age 25, she became one of the youngest chartered engineers at RAES. She is a STEM ambassador. She is the co-founder of a STEM outreach charity called Epistemic, where they focus on virtual engagement. I'm excited to talk to her about that later. And she currently sits on various boards and committees for both RAES and IET. She was awarded the Sir Henry Royce Medal, IET's Young Woman Engineer of the Year Award. Also, the RAES is Young Engineer of the Year, and also their Young Person's Achievement Award. If that wasn't enough, she is also training to be a pilot, and she is currently an analog astronaut, which I'd like to learn a little bit more about later myself. And she's completing her mission, and she completed her first mission for Lunars in 2023. So, Miss Sophie, I'm really excited to have you. Sorry for all the aerospace engineering students. I have her for the day. I'll be asking them their questions later. Okay. So,
It's good to be here.
Thank you so much. So I think the first thing I wanted to get started with was your early career path. So how did you go into aerospace engineering? Was it always your chosen path?
No, is the short answer. It definitely wasn't. I didn't really know what engineers were when I was younger, like at all. I thought like an engineer was someone that fixed a washing machine, fixed that like dish up. Like that was the only exposure to the word I had. I don't from a science or an engineering or like military background or anything. So my dad's a carpenter and my mum's a teaching assistant. So it's just not on their radar as a career for me. But I knew I was really good at maths. I didn't really know what I wanted to do with it until I was 16 and I went to Kennedy Space Center and watched a video about this woman on Mars, and I was like dropped a family with a photo or something. And the tagline was something like, "This could be you." And I remember sitting there at 16 and having all of these things that I really loved and really enjoyed. Like I liked the maths and the science, but I also really liked being sporty and arty and like also like talking and working in teams and like doing like taking on challenges. I loved all those things and I wanted to be everything. I wanted to be a scientist, I wanted to be a ballerina, and I wanted to be a vet, and I wanted to do all those things, but I was like, I can't do all those things. And when I saw this film and I saw like This Could Be You, it was like all of those different puzzle pieces of my life kind of floated in and fitted into that picture. And I was like, that's what I want to be. I want to be an astronaut. Now it makes sense. So that's kind of what I've always wanted to do, what I wanted to be. And I came back to the UK and I did a bunch of different things to try and help me get into that world. And I started studying maths at university just because it was the subject I was strongest at. And I kind of thought, there's nothing to go wrong with maths. Like, the great thing about it is that it opens up so many doors and closes none. So I studied that, and then I entered a competition called Our Space. And Our Space was just a competition run by Queen Mary's, funny enough, and a bunch of NASA astronauts to enter anything to do with space. So I entered a very nerdy video, which unfortunately is still on YouTube, about how the physics of space, or the lack of atmosphere, more like, could actually enable you to enact video games in space. So I went like full like how could you do Tetris? How could you do pinball? How could you, like I went to Quidditch, like I did the full suite. And how would it work? And so I won the Garrett Games Prize and met Helen Sharman, who's the first British person in space. And she was the first person. I was 19 when I met her, and she was the first person to say, like, have you thought about engineering? And I was like, no. So she kind of opened my eyes to that fact that engineering is not just like spanners and oily overalls. It's about, coming up with solutions to problems, and it's inventing things, and it's like taking on challenges and doing the impossible. And I was kind of put from there. So I tailored my maths degree towards applied maths, and which is like very much things like fluid mechanics and relativity and things like that. applied it to that. And then through my third and fourth years at university, I did an internship at BAE down in Christchurch, doing software engineering. Had never done any software before in my life. But mathematics and software are like hand in hand. But yeah, I applied for that one, like just Googling British engineering companies, found it, applied for it, and for some reason they gave me the job. And I really loved it, really enjoyed it. And so once I finished my master's, I went back in the graduate scheme. So quite a long answer to what should be a nice short question.
No, it was great. Lots of advice along the way as well. I think that's actually a really good segue into what I wanted to go into next, which was more about how you would, I guess, give advice to students that are looking to pivot into engineering, because I know not all of us start there, especially those of us that didn't exactly have that STEM upbringing or somebody in STEM to be like, you should go into this right away. If you don't have it, it's a lot harder to get in. So how would you suggest that students pivot if they're now looking to get into it?
Yeah, it's a really good point, and you're bang on. Like, there's so many people that don't get the exposure young enough to sort of like dictate them towards university or apprenticeship to the right age. But then we lose out on so many great minds that could be working on really cool things. So I don't necessarily have advice. It's more a case of a myth debunking, I suppose, is that you have an engineering degree to be an engineer, and it's not true. You need a STEM-based degree, so any of the sciences, but you don't need to be and then like do engineering at university to become an engineer. And there's two routes you can go to: the apprenticeship route, which is like on the job / academic training at the same time. But then also you can do a degree in maths like I did. You could do a degree in software. You could do a degree in robotics, whatever it is. You could do a degree in physics, biology, chemistry, all of their spin-offs. That you can do a degree in any of those things and lead towards engineering. And there's certain types of engineering that need like as much diversity as possible. So, for example, human factors is a really great part, which is like where you look at, okay, from an aircraft perspective, if you're the pilot, whether that's on the ground flying something, a drone up in the air, whether you're in the cockpit itself, being able to actually control the aircraft and thinking, if you put that button there, then it means I've got to reach over in an emergency, I can't get to it. And like designing that actually you need more than just aerospace engineers. You need like psychologists, and you need people with like real design skills, and you need people who are very empathetic. So there's like a real difference, like in like there's so many different parts of particularly aerospace engineering, but any type of engineering, there's so many different parts to it that whatever the sort of like the background learning you've had, it will help you in some way, because it's basically training. Any STEM subjects at university is training you how to think and how to create solutions to problems. That's all it's doing.
Great. And mentioning these multidisciplinary teams, I noticed that you've actually led quite a few of those yourself. So if you wouldn't mind talking about how that experience is, like when you're trying to lead so many people from so many different backgrounds. I know for us, it's just group projects, which is already small, but when you start going into these huge teams, how do you navigate that?
Yeah, and it is a bit of a learning curve. And it's not the easiest thing to do particularly when you've had a specialism and then you try and move out of your specialism. And I think one of the key things that has really helped me, which is funny, like we've just been talking about, is the fact that I don't have an engineering degree. The fact that my background is in maths. I entered the workforce, as it were, thinking I know nothing. Like I don't know how like any of this works. And so I need to trust other people that they know how their part works and that they've got a handle on it. So they can teach me, and I'm always open to learn, and I am not afraid to ask the stupid, most obvious questions, because 9 times out of 10, everybody's asking the same question, and just not brave enough to say it. But it's very much a case of like, you have to be able to trust those people and their expertise. And so you can do what you can when you recruit into a team and try and get the right people and the right behaviors. But ultimately, you have to trust them that their knowledge is like sufficient to be able to support you as a team. And your job as sort of like a multidisciplinary leader is to sit there and challenge their process. Say, okay, have you gone through all of these things? Have you spoken with this person? Have you taken it up with this person? Have you gone through this? And basically challenge them rather than necessarily try and become them. You will never be able to become an expert in any of those things. And the second you can let that go and go, I am not going to be, I don't know, an avionics specialist. I'm not. I never will be. But as long as I've got the people around me that are avionics specialists, and I can challenge them when I've given them a challenge or a problem, or they're trying to come up with, trying to progress a project, and they're part of that, and I can go, okay, how did you come to that conclusion? And if the way they've come to it is from prior experience, then that's one way. If they've come to it because they've been working with academia, if they've come to it from working with another part of the team, but understanding that and then going, okay, so top priority is always safety. So what's the safety implication of this? Okay, my next priority is going to be sustainability. So what's the sustainable implications of this? My next priority is going to be the resource outlay. And going through and just going, okay, what are all the implications of taking this option? So it's about trusting them and then challenging how they've got to that answer. That's the best way that I can describe to doing multidisciplinary teams.
Wow, it sounds very exciting. I think just for the students that maybe wanted to work in BAE the way that you are, could you describe just, I guess, a typical day for yourself as one assistant chief in electronic products? What's the day like?
Yeah, it's I'm in quite an unusual job at the moment. It's split between an awful lot of different things. So we have key partnerships that we work with to develop different products that we can then apply to either military application, or we apply to sort of like what we call special operations, so like mountain rescue, for example, or like emergency reaction, things like that. So the typical day varies so much. And if you ask me this week, for example, I'm spending an awful lot of time trying to build a spreadsheet with a ridiculous amount of data. And so it's not quite as exciting. But if you ask me like next week or the week before, then I might be like in workshops all day trying to like come to the solution for how we might tackle a particular problem from the customer. We might be out with the customers. We might be out with partners. We might be doing a ground-based demo. We might be doing a flight test. There's so many different things that we get to do. And when you're in sort of this multidisciplinary part, you get to touch so much of it that you have to have an appreciation for everything, but you also get a lot of variety in a really good way. So I'm not sat at my desk 9 to 5 every single day spreadsheet coding, and I'm not sat at my desk doing Python or whatever else every day, and I'm not MATLABing every day, but those days appear. Like, do you know what I mean? So, yeah. And I do get worried when I talk about this. Like, every day's different, as though like one day you're going to be on the airfield, and the very next day you're going to be doing spreadsheets, and the very next day you're going to be out on a boat somewhere doing something. Like, it's not quite that varied. Like, it's not like literally day to day, but like it goes in ebbs and flows. So there isn't really a standard day, but there will be like periods of time when you're just working on documentation. There'll be periods of times when you're just working on flight tests. And there's a series of different things. And I think pretty much every engineering job is like that. There will never be a point when you're just doing the same thing day in, day out forever. Like there'll be periods of doing the same thing, but not forever and not for months on end. It just doesn't work that way. We kind of can't. The projects have to progress, and you have to progress with them and change with them.
I think it's good to get that realistic, I guess, side of it. Because I think when you go into engineering, it sounds very practical all the time. And I think that's what we're all looking forward to. So it's good to get that realistic view on it as well.
Yeah, it is. You do have to be realistic with it, because people come into any company, not just mine, but they come in and going, oh, I'm going to be working on flight test. And you're like, well, flight test is only like the actual flying is maybe like cumulatively like a month a year. So for the remaining 11 months, like you're doing other things to facilitate that flight test, not just the flight test itself. Whether that's like writing procedures or applying for like the licenses that you need, or doing the training you need, or whether it's maintenance. Like, there's so many things that you have to do to facilitate that. It's not sat there going, oh, I'm going to strap this thing onto my drone and get flying like today. It doesn't work that way, unfortunately.
A little bit disappointing, but it makes sense.
Like, I feel like I need to prepare you for that. Like, it's not
appreciate it.
But like it's a lot of days depending on what you do, and it depends on what type of company you're in. And it depends on like what type of project you're working on. If you're working on something like an existing aircraft that's been flying for years, like if I take Typhoon, F-35, those sort of aircraft, you probably are going to see them flying more often. You probably are going to be a bit more hands-on. But if you want to be working on something that is more future based and you're going to be looking ahead and going, okay, I want to be working on the next green aircraft, or I want to be working on the next hypersonic thing, or whatever it is, and like what I would call sort of like doing legacy work, as in leaving your own legacy. You're going to have those days of up and down, and there's a lot of things you have to get in line before you can go and fly those things. And a lot of it is people work and getting people on board. A lot of it is paperwork. So it is unfortunate. But as long as you've got a good team, it goes by. And that's the important thing, is getting the right team around you.
It's good to know. I guess I wanted to pivot a little bit more into your experience thus far, like especially in your career, as successful and as you are. Like I mentioned before, that you had won so many awards at such a young age. I wanted to ask a little bit more about your perspective as a woman in your career. Would you notice any challenges or hurdles, or any, I guess, advantages as well that you might have noticed? Anything that you can share with us young people as we get into it?
Yeah, sure. And it's something I used to almost shy away from talking about, but I don't necessarily anymore. And I think when I was younger, I didn't necessarily see it or understand it or notice it as much. And as I've got older, I've noticed it more. And particularly coming from a maths background, maths is like 50-50 male female. Like it's not male dominated in the slightest. So when I did join BAE, I was a bit like, whoa, where are the women? It was more of a culture shock than anything. But I didn't really see any disadvantages from it. And I was treated like all the other graduates, brought in on the same pay grade, you brought in given the same levels of work. I didn't see it. And it's only as I've got older and got more influence, and particularly going outside, and I'll go to an awards dinner, for example, and we'll be asked about whether I should have had kids by now, and things like that. And it's just it's that kind of little chipping away that happens. And it's not necessarily holding me back, it's not stopping me, but it's those kind of I can't think of a better phrase than a microaggression that just kind of builds over time. And particularly as I've got more senior, I've noticed people not realizing that. So I'll go in and people won't realize that I'm the one running said meeting, or they won't know that I'm the one with decision making power, or I'll have someone come in, and I've had particularly often young apprentices and apprenticeships will come in and be ask me for the lead engineer, and I'm like, it's me, I'm speaking to me. Or they'll ignore me. They'll come in, and if it's just me in a room, they'll ignore me and then won't start speaking until a man comes in. And it's really little things like that that you kind of, it's not conscious. It's not outright sexism when people are oh gosh, you can't do this because you're a woman. There are people like that. They're in a minority, and they're actually quite easy to shut down. They're the easy ones to deal with. It's that sort of underlying insidiousness with it, where you're just it's an unconscious bias basically towards it, and trying to explain it to people without making them feel guilty about it is really challenging. But it's definitely improving. And I think what really helps is, as I've got older, I care less about calling it out. So I will talk about it, and I will make people feel awkward, and to the point where I've got a young woman on my team now who is brilliant. She's a great engineer, and I'm constantly having to bat away assumptions from people about her because of that. And it's one of those now that I'm in a position of power, I can make it easier for the next people coming through, so I will do. And that's the same with any woman that gets into those positions of power. We help each other through now. So it can be challenging, but you do get this network of women that then hold on to each other. And the Young Women Engineer of the Year awards are amazing for that. You get a real community of people who really lean on. We have our WhatsApp group, and we have our reunions, and we speak to each other, awesome. And and you get to know that this is the same thing that they're facing, or it's not the same thing they're facing, or just a general these people are so ridiculously talented, and their ambition is so high, and they're just really amazing people to be around. It just enthuses you as well, inspires you to keep going. So you do get those really great networks as well. So there's twos and fro's, pros and cons, and difficult days and less difficult days is the best way to describe it. But it's getting better, it is improving, and I don't want it to ever be something that puts people off it. Because otherwise it's kind of going to be a self-perpetuating thing. So
I agree. So I guess what I wanted to finish off with for this little section was how I just had noticed when I was, I guess, coming into engineering, so many warnings, I guess you can say, of people being like, oh, if you go into engineering, you're going to be constantly having to deal with this adversity, which is a problem, of course. But I think you're right. It's been more of a microaggression thing that I think, and I would love to change the narrative on that.
Yeah, and the thing is, like, we talk about it, and I do worry that people take it as like every single day I'm batting this up. No, it's not every day. Like, it's some days. Like, I'm not gonna lie and tell you that it's all sunshine and rainbows and everybody's equal and fine. Like, I can't lie to you about that. But like, and that's, I just want to make that clear. That's not my company issue. That's a aerospace wide issue. And it's, but there are, like, most of the time it's fine. Most people are fine. And there's no like real like aggressiveness to it. It is just those like small microaggressions that when you call them out and you are consistent with it and other people back you up and you can get those allies, like, it's really important. I'm really lucky that I have a team of people that work for me that will stand up and say, did you mean to ignore her? Like, and it's like it's that, like, having those people around you makes a difference. So it sounds scary. It's not. It's just something to be aware of, that it will happen, and you've just got to be prepared for that. And how you face that and how you deal with that is a personal choice. And I can give you my way of doing it, but it's personal, and everybody deals with it differently.
100%. Okay. So I would like to switch over now to some of the more exciting techie things, more technical, exciting things. So I wanted to go into your time as an analog astronaut. So for those of us that don't quite know what that is, would you mind explaining what's an analog astronaut? I think we all hear astronaut, but never the little underneath terms.
Yeah. So analog missions are basically simulated space missions. So they're done on Earth. Or underwater in some cases, and they basically simulate what a mission would actually be like, and then they'll test a number of different things. So sometimes it could just be like a psychological test. So a lot of the ones we did in my last mission were psychological, in terms of being contained in a very small space without sunlight, without sugar, without caffeine, with basically five other strangers, like, and sharing a bedroom with them, and like, and all of that, having no privacy, and like that kind of thing, and then like having little sleep and not having your normal circadian rhythm, and all of those things where they have to like study that and understand that impact. But particularly for long duration missions, whether that's to the moon or Mars, they're going to be important. So that's the psychological side. Then there'll be like equipment they want to test. So we were doing like sports equipment, for example. So exercise is super important when you're in space. So making sure that you're using the best equipment, or equipment that is lighter weight, because the stuff they're currently using at ISS is like big, heavy machinery. So can they create lighter weight versions of things that don't require so much space and energy and mass to get up into space? So things like that, or like different like geological tools, different rovers, different like types of technology that they're playing with. There's then like a bunch of different tests, like procedural tests. So understanding, okay, if you've got an astronaut out on the lunar surface, if you're on the moon, of course, astronauts inside the habitat, and then astronauts in the gateway, astronauts on the ISS, and then ground control in like 10 different parts of the world, how do you communicate? Like, who's most important voice? And what happens in an emergency? Or what happens when you've got a problem you need to solve, that you need different parts of that chain to be speaking to each other, and then other parts of the chain need to be speaking to each other, but they can't talk at the same time? Like, how do you deal with that? And it's that kind of thing that we've never really had to worry about before. So, for example, when we were doing the Apollo missions, and to an extent some of the Artemis missions, it's quite simple in terms of you had ground control, and you had the astronauts in space, and then when they landed on the moon, you'd have the ground control, astronauts circling the moon, and then there's two astronauts on the surface, and that's it. Those are the three. And to an extent, the one circling the moon was kind of like taken out the comms loop until they had an emergency. So it's quite simple. But when you've got so many more different nodes to that chain, it makes it much more complicated. So we were looking at that as a procedural one. So we did a test with the ISS, the Columbus module mission control, to try and work out, okay, what does this work? Does it not? Is it quite like superfluous to have all these people talking to each other? How do we want to do it? And it was very early days. And there's a bunch of different like examples that you can give about procedures and processes, like how do we want to put a spacesuit on, what do we want to do in an emergency, what happens if there's a solar flare, like all of those different things. And it's from a people perspective, what do they do, like how do we create those procedures and processes and put them in place so that when we do go to the moon or go to Mars, that there are like these things we're prepared for, because it's a very volatile, very dangerous thing to do. People forget how dangerous going to space is. It's not just hopping in an airplane. Like, it is a very dangerous thing to still do. And so you have to try and prepare for everything. As that NASA saying goes, prepare for the worst, hope for the best. And you kind of have to have all of those things in place. So analog missions help that. They're not the only way of doing it, but they help that. So there's some that they'll do with like actual astronauts to kind of prepare themselves for space as well. So the one Nemo is a really famous one, which is the underwater one off the coast of Florida. So they'll go underwater for 10 days or however long they need to go underwater for, just to prepare for that sort of like psychological, I'm in somewhere that I can't just escape when I want to, and I have to like don suits, I have to repressurize, and I have to do all of these things before I can leave. And it's just psychologically preparing them for that, because that's quite a big thing. So there's a bunch of different things that analog missions do. Analog astronauts are just the people that are doing it. So they're like they're on the lunar surface, but we're still on Earth. So like when I did it, I did feel like I wasn't on Earth anymore. It was very strange, but it was an amazing experience, and I absolutely loved it, and we'll hopefully be doing many more. But it's it's an unknown part of that human spaceflight journey that people don't know about, and know that you can go and do and be part of.
I certainly didn't know that analog astronauts were a thing until I actually read it in your bio, and I was like, what is that? Definitely a huge thing. So I guess it sounds like a lot of collaboration work as well, like you mentioned, making sure that everybody's communicating. And then something I hadn't thought about, which is prioritizing that communication. I just kind of thought, everybody be talking, you can hear them right away, but not, maybe you're not in the communication loop for a certain amount of time. It just, that sounds like quite a lot.
And then there are things like what happens if somebody loses their communications, which is something that happened to us, like as in like I don't want to call it an emergency, but a real situation where I lost complete comms to everybody, and you can't hear anything when you're in the suit, like if they're talking to you. So you have no way of communicating with ground control or with their Habcom. And so you're just like basically sign language into another astronaut, trying to get them to understand you. You can't hear them and they can hear you. And then trying to communicate, okay, do we carry on the mission? Do we go back in? What do we do here? And having to have that sort of like three-way communication where one person can't speak. It's tough. It's not easy.
What an experience. Wow.
One I wish I had had, but
you got to try it at some point, I guess.
Good to know to deal with it. Yeah, it was quite validating in many ways, that mission. We had a couple of like genuine emergencies, and it was quite validating to know not only when the emergency happens to me that I can stay calm, but also when the emergency happens to somebody else and I've got to be the person saving them, that I can do that and I can stay calm and clear-headed and get it done. And it's quite validating in that way. Like, you don't get those tests very often, so
that's true.
It's nice to be able to have that test.
Wow. So is this the Lunaris mission in 2023? Just to confirm for everybody.
Yeah, that was that one. Yeah. So we had a couple of instances with a ventilation system on a suit that happened on two spacewalks in a row. So
wow,
fun and games.
All a part of the thing. But I wanted to ask as well. Sorry, just double checking in my little notes here. So, from your Lunaris mission experience, what do you think are the key considerations for future lunar and Martian spaceflights?
Oof, good question. And they're both very different. We have a habit of like combining lunar and Martian missions together in our heads, thinking, another planetary body. Not just you, like we all do. I do it. I've said it several times. Is because we think, another planetary body is not just orbiting. Orbiting is safe in quotation marks, because it's definitely still not safe, but it's known, shall we say. Whereas lunar missions are not so known, and Martian missions are less so. And where the difference comes from, or such an extreme difference, is the distance. And I don't think people realize how big that distance difference is. You go from taking like up to a week to get to the moon to several years to get to Mars. And that's a very different time frame to be thinking about. And then not only that, you've got to come back. So for lunar missions, it's more about, okay, how do we establish a settlement there? How do we get time there that we can have long duration missions to the moon, keep people there for a long period of time, have a permanent habitat, get more science and learn more about the moon, find out what's going on with the ice they found and all of those different things, and understand, can we actually live as humans in a self-contained entity on another planetary body? We don't know if we can do that. So that's a very different approach. Whereas Martian missions are about, let's get there, find out what's there, and then hopefully come back. Is the coming back hopefully very difficult? Yeah, hopefully, yeah. And I do genuinely say hopefully, because when the first lunar missions happened, there were 2 speeches written, and it was one for if they succeed and they land back safely, and one for if they don't, because it was 50-50. They didn't know. And Martian missions, I'm hoping, will be slightly more, whether it's less 50-50. Yeah, you'd hope so. But there are genuine sort of like missions or approaches where the mission doesn't come back, like intentionally by design. So you send people to Mars and they stay there for the rest of their lives. I personally don't think that's necessarily the best thing to do. I think like if you're going to be doing this space exploration, you're going to be committing all your years of life and energy and resources and all these things that we do to this, you want those people back because they need to be able to tell you what they found. And like the lag in communication between Mars and Earth is like 10 minutes. So you can't have those like natural conversations, and you can't inspire people, and you can't share. And like one of the most important things about exploration is coming back to share what you found. And so for me, I think that's really important. But there's other things, that the fact that it's so far away and does take years is, okay, well, are they going to stay awake, or are they going to go to sleep? Are they going to hibernate? And then you've got things like, okay, well, how do you have food? Is it all going to be freeze-dried? Can you live on freeze-dried food for X many years? Or do your teeth start to disintegrate? Another thing they checked on one of the Lunar missions is like the effect on your teeth when you're eating freeze-dried food. Other things like, okay, well, if you're going to have medicine, some of it needs to be refrigerated. So having a refrigeration system on board is a very heavy system, and a system that can go wrong because there's so many parts to it. So is the risk worth it? Maybe, maybe not. And so you're always having to think about everything, about the basics of what you're doing in a completely different time frame. It's like if you go camping for a week, you bring the food you need and you bring the equipment you need. Going camping for a week is one thing. Going camping for 10 years is another. You need different things. You need to rethink everything. Will your tent hold for 10 years? Probably not. So will your rocket hold for 10 years? Probably not. So how are you going to repair and replace your rocket, which goes to who are you going to send there? Are you going to be sending scientists who understand geology and all those things? Or do you need to send technicians who understand how to replace a refrigerator? What do you send? And it will be a combination of that. How many do you send? Do you send people who are, and this one's a really interesting one from a psychological perspective, of do you send like families? Do you send a couple? Or do you not? Because otherwise we're sending people on their own. And in which case, do you facilitate things that you would not normally facilitate on a space mission or not? And it's a genuine question. It's a genuine concern, because we're human beings and 10 years is a long time.
Yes.
So you've got to think about these things. It's a very, very different like mental frame that you need to be in for Martian missions than you need to be in for Lunar. And even the rockets will be different in terms of like the size and the sheer power of those rockets, and it's so much higher. And it will probably be like, the way that I view it is that the Lunar missions are like a stepping stone to Martian, but they're completely different. So you still have to be able to understand that mission is going to have to be structured differently, even if you use the learnings that you get from the Lunar missions. Even if you slingshot from the moon to get to Mars, you still need to have a completely new mindset when you're thinking about those Martian missions.
That's a completely new word for myself, but I'm really enjoying learning about it. I think the camper analogy will really help, especially for people that didn't really know about all of this before. It's good to like liken it to something that we can imagine ourselves in. Then I used to go to camps when I was younger, so I'm just picturing like, could I stay there forever? Probably not.
Yeah, yeah. There's like it's a really strange one. It's even like not seeing like nature. So would you send plants with them? But then there's an extra thing you kind of have to deal with. So would you? Or like similar things like not feeling water dripping on your head is a psychological element of that. Like never feeling the rain, or obviously in showers and things, you can't shower. So how long can your skin deal with being wiped down? And we've done long duration missions to the ISS for 6 months to a year. That's it, and not 10 years. So I'm choosing 10 years as an arbitrary number right now, but it could be that long. It'd be several years, if not longer. So could you deal without having a shower for 10 years? Probably not. Like, yeah, exactly. It's a thing to think about, and how they would deal with that.
I'm just finding it so fascinating, all these new considerations that I hadn't even thought of before. Just like the little things that you wouldn't really picture yourself thinking about because you're so natural. You're so used to being able to like wake up and shower, wake up and brush your teeth. But if you're on a spaceship, then you can't really do any of those things. And that's wow.
Yeah, and like being in water conservation mode, like 24/7, which is you'd have to be. So like even on our mission, we had to be in water conservation mode, which meant like when you brush your teeth, all you could have was like a little cup of water, like this much, and you dip the toothbrush in, and then that's it. And then you have the tiniest left to spill out, and that's it. So there's no running. Like there was running taps on our mission, but we were trying to minimize the amount of water. So you can't just like run your toothbrush under the tap. You can't just splash your face with water. Like you can't do that.
Wow.
And how does that impact you as an individual? No one really knows.
I guess the next thing I wanted to focus on is that you are currently training to be a pilot, which is very exciting. So if you wouldn't mind telling us a little bit more about that process.
Yeah, I mean, it's quite a simple process. Everyone seems to think it's quite complicated. So it's actually not too bad. It's kind of like your driving test, just a bit harder.
In the air.
Just a tad harder, but you do, just like you do your theory exam for your driving test, you do between 9 and 11 ground exams, depending on certain circumstances. You need a medical check, just to make sure that you're not colorblind, for example, or that you've got full hearing, or like you can see, like all of those things, that you're not like you're physically able to do it, because obviously it's much more. If something goes wrong and you see the wrong colors and you crash into another aircraft, that's probably a bigger deal than crashing the craft. So you have to have a medical, and then you have to have a certain number of hours. So it's a similar thing to your driving. You have to have a certain number of hours before you can drive on, go through your driving test. And it's the same thing here. So you have to have a certain number of hours with an instructor, and then a certain number of hours solo. So once you've hit, I can't remember the number off the top of my head, but it's something like 10 hours, I think, maybe not even that, probably 15 hours. I'm not sure. With an instructor, and you've done one of your ground exams, you've done your air law exam, you can go solo if your instructor thinks you're good enough. So getting in an aircraft on your own for the first time, like anyone that's learned to drive and gets in the car on their own for the first time knows like how euphoric that moment is. It's a whole new level when you get in an aircraft on your own, because it's that mix of like super excited and like completely euphoric to be in the air on your own, thinking I'm doing this is all me, there's no like I'm doing this, but then also that mass amount of fear where you're like it's literally just me. Like it's like, if I don't do this, if I get this wrong, then that is it. So like the stakes are higher, but the euphoric feeling is better because of it. So you get to that, you do your solo, and then once you do that, when you're doing the next like set of exercises, next set of things to learn, like when you're driving, you learn your maneuvers. Like you learn instead to do like stalls, you learn to do navigation across country, you learn to do different like skills basically. And when you're doing those skills, once you've gone solo, you do it with your instructor, and then you go and do it on your own. You do it with the instructor and go and do it on your own. So there's a syllabus that you go through, and then you do a skills test, just like you would in your driving test. And you sit with a different pilot and you fly them, and they'll tell you what to do, and you do it. And then if you fly well and safe, then you pass. And if you don't, then you don't pass. And that's basically it. Like it sounds, like people think, oh, you get your pilot's license, and everyone's like, wow. And I'm like, it's not like, it sounds way like scarier than it is. Like, and I think the scariest thing is just the cost of it. Like it is expensive. that is the hardest part of it, is like getting that. I'm very fortunate that I get to fly what I get to fly when I get to fly it because of my job. But like, it is a very expensive thing to go and do. And some people tackle that different ways. You can get scholarships from like the Air League and things like that. But also some people save up all the money, so they've got it all ready, and then they can, when they're ready to fly, they can just fly and they're not going to get stopped because of that. Which is what I did, because I didn't want to get halfway through and then run out of money and be like, oh, I can't actually get the license. Or some people just pay as you go, as and when they have the money, and take that risk of not being able to afford it in the future. But it is quite time intensive. It's not, driving tests was much easier time wise. It's much more time intensive. And you have, like, particularly the ground exams, like the actual flying, it is time expensive. Like, if you're going to be flying for an hour, that's your whole afternoon gone, because the amount of time you do prep work and post work, and it's your afternoon. But it's the exam that take the time, because you have to sit all the exams, and the books, I've probably got them somewhere, but they're like chunky books that you have to just know by heart. There's no, like, it's not like maths where you learn a way of doing it and then deduce it, or like engineering where you know the principles and you solve a problem. No. It's like, what article number is this rule? Like what's the number you need to pull when this happens? Like, you just have to know it, and it's a memorization game. And so that is the hardest part, I personally find, because of the time that it takes to be able to do that. But the subject itself isn't hard. Like, anyone can learn it. It's just time. And so I've had to pause my training because I'm doing my master's part-time, and so it's just too much to be doing them both. But I will be picking that back up when dissertation is finished on the 29th of July, and I can't wait.
Congrats in advance. So just for the last little bit of the session, I wanted to go back to the student questions, because I already know that they'll be very upset with me if I didn't ask all of their questions. So I guess I'll just start off with the first one, which was, what would you say would be the current struggles or challenges for aerospace engineers?
Or
just people in your field would be easier.
Yeah, I'd say for the industry, the number one challenge is the green challenge, 100%. There's no like question about it. Like, it is a really, really big challenge, and trying to explain how difficult becoming sort of more sustainable. And I don't want to say sustainable, more sustainable, because it's not, or will never be 100% green. It's really, really difficult, like both technically and financially. Financial part is slowing a lot of things down. So it is very challenging, and you've got so many different routes you can go down. You can go down the electrification route. You can go down the sustainable aviation or SAF route. You can go down the hydrogen route, hybrid, all of these different routes, and no one can really back the right horse. And with all of those things comes a whole new level of infrastructure that needs to change with that. So rather than just a fueling station, suddenly you've got two different types of fueling station and a charging station. And you can't have those two fuels next to each other, because they're both flammable, and one more so than the other, and would take out, the whole airport if they exploded. You've got another one that's like, okay, well, that electrical spark can't be anywhere near any of this. And then like you basically have to have this mass infrastructure upgrade that's going to be needed. And on top of that, the amount of energy that you need to be able to generate the fuels or to charge the aircraft is massive. And if you're not getting that from a green source, then you're just moving the problem. So there's a number of different things in that green space that is making it extremely difficult. But it's the number one challenge that everyone's got to solve, because if we don't solve it, then, not to get too existential, but obviously it becomes a big challenge for the world. And while the emissions from aerospace is quite low, it's like between 2 and 3%. Like, people don't realize it's not actually that big, but it's per person that it's massive. Only 20% of the world fly. So 20% of the world are responsible for 2 to 3% emissions, which is not right. It's not fair. So that's why it's such a big problem. But that is a really big issue. So anyone that can get to grips with those challenges, gets any experience in those worlds, and can appreciate that system to systems, that really difficult thinking around how you make it truly sustainable across the whole thing, how you tackle those challenges and consider so many different things, is going to be like gold dust. Like, get them people. They are superheroes. Like, you need those. And it's great to work on those projects because you feel like you're really like making a difference, and that's really nice. There are additional challenges out there, like AI is going to be a big challenge, and things like cloud computing and the cybersecurity elements of that, particularly in like the defense space. It's a real challenge, where we don't really know how it's going to shape up. Like AI in particular, we don't really know how that's going to be regulated, and aerospace has to be regulated like heavily. So it's like, well, how do we do that? Or do we just ban AI from being used and the industry falls behind? And it's a real difficult word. So again, anyone that understands that would be gold dust too. But in terms of like individuals for engineers, it's that shift that the traditional way of doing things kind of can't continue. And we have to find ways to still hold ourselves accountable, still have those safety levels that the aerospace industry prides itself on, because safety levels of aerospace is beyond any other industry in the world, like incredible in comparison. And it's keeping hold of that, while also adapting to these new ways and faster ways of doing things. And that's more of an individual challenge that a lot of aerospace engineers are going to struggle with. And we need to make sure that we're helping as many people as we can with that, so that we keep that safety consideration whilst also moving towards the modern way of doing it.
Thank you. My next question from the student is, have you ever felt like you've maybe lost your passion while you're going through your career? Like I mentioned before, you've had so many different achievements, different things that you've tried and enjoyed. Have you ever felt that you've lost that passion, and how do you find it again if you have?
Yeah, no, I would absolutely be lying if I said I hadn't. And I think anybody that tells you that they've never lost their passion or lost their enthusiasm or ambition for something is lying to you. Everybody does. Like, even when I was at university, I was like, oh, I'm not quit this. I can't do any more maths. No more Greek letters, please. Like, everybody goes through that. And it would be such a lie to say that we haven't. And there's a number and one things that you can do to go through that. For me personally, I think about like my day to day, and I think, okay, what am I losing passion with? Am I losing passion with the project, or am I losing passion with like my day to day issues? And often it is day to day, and it's not the project. And it's things like, oh, I don't like for me, working from home is not actually what I enjoy. Like I can do it, and I don't mind doing it often, and I enjoy the flexibility it gives me. But I actually prefer being around people. I like working with people and workshopping things and coming up with solutions to things. Like I love that. And so for me, I was like, right, okay, that means I need a team. I need a team around me to be able to do that. I need to be able to like have that in my head that I can go and do things in person with people, change the way that I'm doing things. Like particularly in my company, we do a lot of our work on the phone rather than on video calls. So I don't see faces. And so shifting that kind of culture in my team to be like, okay, these calls are now going to be video calls. And I don't want to do that from like my manager's making me turn my camera on. Oh, my manager's making me come into the office. I don't mean it like that at all, because I'm always going to be flexible people. But more of can we trial some different cultural things to try and get that drive back? And I think in engineering, that's really important. And particularly for my younger team members who have never been in the office full time, they don't know what that's like and how like infusing that is. And it's not the case for all jobs. Like if I was possibly an accountant, I possibly would have a different view. But like as an engineer, you do need to be in teams for team sport. So rephrasing my day to day is like what I look at now. And then sometimes it's the opposite. Sometimes it's the project. And I go, I don't believe in this project anymore, or I don't want to be working on this project anymore. And so, for example, the current projects I do are all sustainable projects or sustainability projects in general. And I like that. I like feeling like I'm leaving a positive legacy. That's my number one driver in everything I do is, am I leaving a positive legacy? And so if I was moved off that and put onto a project that wasn't necessarily doing those things, I probably wouldn't be as passionate about it. And so when I'm choosing next roles and jobs and what I want to do and thinking about what my next steps are, I've got to have that bigger picture in my head in terms of, am I really going to be bought into this project's vision and what it does, or am I going to be sort of just doing the work for the sake of doing the work? And if I'm in that latter part at any point, then I have to move. I have to leave. I have to change my move. I can't do that anymore. because and there's a bit of advice somebody once gave me, like, you can't view your job as a job. You have to view your job as a mission. And if you view it as a job, then you will only ever do that job, and you will never like get that satisfaction. You'll just get the job done, and that's not satisfying. But actually achieving your mission is, or trying to achieve your mission is. So that's kind of like how I look at it. And I go, okay, if I'm not doing something that makes me feel like I'm achieving my mission or leaving a positive legacy, then we're done here. We don't do that anymore.
I love that. And I think it really goes back to what you mentioned earlier about doing legacy work, just looking out for the future and you wanting to be making that impact. So thank you for that. It's really good advice. My last final question, sorry for everyone, last question, but I wanted to just ask a little bit more about, I guess, how you manage your time. Because like I mentioned before, you've done so many different things. I didn't mention this one, but she was actually recently featured on the TfL and Royal Academy of Engineering's TfL map, which was so cool to me. I thought that was awesome. And also the different awards and things that you've gone for and achieved. How do you manage that time? I think just for ourselves as young engineers, whenever we think you hear someone like, oh, I'm on the board of this and I have these engineering academy awards and things, and you're like, how did you manage that along with your job? So I guess, how do you manage your time?
Yeah, and there's not one straight answer. And if you ask me at different points in my life, I'll give you different answers. And it is challenging. It's not easy. And I found that you have to have, it's a lot easier when you have support from your company and your manager. So I've had managers in the past that aren't supportive of it, and I've had managers that are supportive of it. And the difference in just sort of a mental state to go, oh, I do have flexibility to deal with this, or I can go and do that, and my boss going to be okay with it. And like being able to have like a board meeting in work time is very helpful, because we sponsor the boards, and we sponsor the institution, so it's part of that element. So I can do it in work time. Doesn't mean that I necessarily then take 2 hours off of my week, for example, to do that board. It means that I end up having to still do those hours, but I can do it during that time, if that makes sense. And there's just an element of making sure that you're prioritizing what you want to prioritize. I got into a bad habit a few years ago of just saying yes to everything. And I do recommend that to an extent. I do recommend of saying yes to things and like doing experiences, even if you can't see where they're going to lead, because my most interesting, exciting things come from like engagements that I had no idea really where I was going to lead or who I was going to be. I didn't really know, but I thought, well, I've got the time, I might as well do it. So I do agree with that. But I then got to a situation where I was really, really busy, and I was really like overwhelmed with a lot of things, and I was still saying yes to things, even though I was like, I don't really want to do it, but I feel like I should. And so I had to get comfortable saying no. But it has been challenging at times, and there are days when it's nice and easy and you think, yeah, I can do this, and there are days when it's not so easy, and I do have to use a lot of my annual leave for these sort of things. So whenever I do anything like from media wise, or like when I want to film something, or like do anything for like competitions and things like that, that all has to be done in my own time. And so I spend a lot of like evenings, I won't necessarily block out time. I possibly should, and that might be a better way of doing it. But I know that, evenings I'm like, when I'm sat watching TV, and I'll just be going through and like picking stuff off and getting stuff done. It's become significantly harder since doing a master's part-time. For my advice, if you do ever want to do a master's part-time or a degree part-time or any kind of academic part-time, do it earlier in your career. Don't do it later. Like, you can do it later, but it's hard. It's much, much harder, because you've built up a reputation, you've built up all these other things that you do, and you're juggling a lot more. But yeah, once that goes, I feel like I'll suddenly have all this time back, and I'm like, right, how do I fill it? And I'm one of those people that likes to be busy, not bored. And I genuinely enjoy doing those things. So even though often they're in my own time, they're fun to me. So it's not like I'm sacrificing my own time to sit and write something I don't want to do, and not do the things that are interesting to me. I'm sacrificing my time for things that do bring me joy. Which sounds really, really, Marie Kondo. But like going and speaking with schools and like talking to kids, or like filming TV shows, things like that, are fun to me. They're hard work, but they're fun. So it's a different thing, and it helps like keep my other side of my brain going when I'm not always doing the creative works like creative stuff at work, and I might be doing some less creative stuff at work, going and doing the creative things in my spare time helps. So it just keeps those things alive. So it's, I don't have a stock answer for how to manage time. And I feel like I should have a better like TED Talk style of like, this is how you do it. But the answer is there will be times when you just can't, and you have to say no. But you take it one day at a time, take it one step at a time, and you do what you find interesting. That's my only advice I could give you.
No, that's great. Thank you so much. I don't think there is a cookie cutter answer, but it's still good to know like how everybody perceives it. I guess perceives time management. It's good. It's good to learn from. So thank you so much for your time, Miss Sophie. I really enjoyed our conversation. I'm sure everybody listening has enjoyed it as well, especially getting to learn so much about space exploration. That's my favorite part. So thank you again so much for your time.
No problem. Thanks for having me.
Hi again, awesome listener. That wraps up another deep dive of Kameron's Lab Dive In. Before you dive back into your day, see what I did there? Take a second to hit that subscribe button so you never miss an episode. Want a behind-the-scenes look? Bonus content? Or just some good old STEM fun? Follow me on my socials, Instagram, TikTok, and YouTube at Kameron's Lab. And remember, every episode is a new adventure, and we've got some thrilling dives lined up for you. Don't miss out! Until next time, stay curious and keep exploring.